Alright, today we're going to look at implicit differentiation and just, first of all, different ways that we've learned to write a derivative so far. One thing is when we've had f of x, everything's in terms of x, we can write f prime of x, call it f prime, it means the change in f in terms of x. We also, instead of saying f of x, we could just say y equals, and we would say y prime. Same thing, changing y in terms of x. However, we've had many problems before where x and y just cannot be separated, and it just makes for a very difficult type of problem. So what we're going to learn today is called implicit differentiation, where we're essentially going to say we need to find dy dx, or if we wanted to, even dx dy. The change in x in terms of y, or in dy dx, more often than not, change in y in terms of x. And the way we're going to do that is by implicit differentiation. These are the steps for how to do it. If you want to get these in your notes, that's good. I'll show you here in the next example exactly what I mean by every single one of these steps. So let's get right into an example of how I want to do this. We're going to do a derivative for each term that we have here. Each and every term just as normal, and then with one minor adjustment. So, for example, the derivative of 3y cubed, or of y cubed, would be 3y squared. However, anytime we have to take a derivative of a term with y, we need to also have this term of dy dx with it. So same here, 2y will become, y squared will become 2y dy dx. Minus 5y will become a minus 5 but dy dx. Minus x squared will become a minus 2x. If you want to think about it, technically I should say times dx over dx, because I'm doing it in terms of x, but what is dx over dx? It's just 1. That would go away anyway. Okay, derivative of 4 is 0, and then derivative of 0 on the other side is also 0. So that right there is step 1 to get to find a derivative of each term. Number 2 is to collect everything on the appropriate side. So on the left, anything that has dy dx, I'm going to keep where it is. Anything that doesn't, I'm going to take it over to the other side. So this all will stay the same, 3y squared dy dx plus 2y dy dx minus 5 dy dx will equal a positive 2x. Step 3 said to factor out dy dx. So anything I have with dy dx here, I'm just going to bring it out front. Dy dx, I'm left with a 3y squared, a 2y, and a minus 5. I still have 2x on the right. And then the last step is just to simplify to get dy dx by itself by dividing. So I'm going to have dy dx equal to, I had 2x on the right, and now I'm going to divide by this whole term here and get 3y squared plus 2y minus 5 as my denominator. Look at another example here. We're going to do the exact same thing. This time we have chain rule here. So what we're going to say first is first times the derivative of the second. So first is x cubed. Derivative of the second will be 2y, but it involves a y, so dy dx. Plus the second, which is y squared, times the derivative of the first, 3x squared. There is no y prime or dy dx because the derivative only involves x cubed. Plus, the second term here will be chain rule. Derivative of the outside with respect to the inside times derivative of the inside. It's just x's, so it's going to say 2x plus 1, no dy dx, equals to 0. That's step 1. Anything that doesn't have dy dx, here's the only place it exists. Get everything else to the other side. So this will be 2x cubed y dy dx. I've simplified it. Will equal, on the other side, I'll have, this will become a negative 3, I'll make it x squared y squared, because x will come before y. And then the second term will be minus, we'll say, x squared plus x to the 6th power, and I'll distribute that 7 in here, make it 14x plus 7. Next step would be to factor out dy dx, but there's only one of them. So I'm even skipping step 3, go straight to step 4. Dy dx will equal everything over here, negative 3x squared y squared minus this whole quantity to the 6th, 14x plus 7, divided by anything that was out in front over here, so over 2x cubed y. you 2 more examples to try. I would say pause the video real quick, give these ones a try, and we'll see if we can get the right answer. Alright, here's the work we should have done. The first one should have been pretty straightforward in getting this. So we should have just had the 2x and only 1 dy dx when we did the derivative of the second term. So when you simplify in the end, those negative 2's cancel out, and you should have x over y. For this one, again, you would have had product rule a couple different times. There's all the work for it. If you left it in this form right here, with everything as it is, that's absolutely perfect. If you try to factor out a y on top and x on bottom, that's even better. But those would be your answers for those. So hopefully we now understand a little bit more about implicit differentiation.